Guys, we're live on YouTube and we're doing another show and tell. Wolf will present the new trusted publishing we're building on prefix.dev and Rattler build and GitHub. And yeah, if there's any questions, feel free to come in. We don't have a lot of visitors in the live chat right now because we forgot to promote this show and tell until very late. But hopefully people will see it online afterwards and we can still have some interaction. So feel free to go, Wolf.
Yeah, thanks, Ruben. Yeah, so we did. Wait, let me figure out which kind of streaming I want. I think we want the better text readability. This is strange because
We can see your screen now, yes.
not
Anymore.
for some reason it's oh my god. Well, it's good that we don't have many visitors because Discord or Mac OS, I don't know what changed something about how to select basically sharing everything, which is whatever. Okay, well, this has completely moved. But I found it.
Seems to work.
So, do you see the screen?
Yes.
Do you see the Christmas pixie?
Yes.
Pixie Paxton. So yeah, that's the first thing that I wanted to share. Happy, what is it? Sinterklaas in the Netherlands, but in Germany it's Nikolaus, and I don't know what it is in all the countries that you're visiting us from. In any case, what I wanted to show today is trusted publishing, which is something that we are writing a blog post about, and this one is also supposed to go out today. And the idea is that we basically took a lot of inspiration from PyPI and PyPA, the Python Packaging Authority. And on PyPI, since a while, you have this option to do, I always mix the letters, this option to use trusted publishing. And apparently they have problems right now because I don't really see the button to log in. But there's a selection box where you can select that you want to do trusted publishing from GitHub, for example, or other options. And so we basically copied the ideas from PyPI here. And trusted publishing allows you to publish to a Conda channel on prefix.dev without having to create any API keys or things like this. So everything is sort of completely streamlined, and it works by using OpenID Connect. So basically what happens is that in the GitHub action that is running, GitHub gives you the ability to create a secret token that is signed with like asymmetric encryption, and you send that token to the prefix server, and the prefix server will validate that this is actually coming from GitHub and that this corresponds to, you know, the trusted publisher that you configured. And then it will allow you, and it will basically send back another secret token that is only valid for like 15 minutes. And that token can then be used to upload packages for the next 15 minutes. And so what this looks like in practice, I can show you. Well, so I should have indeed prepared this better, but let's go to RustForge. So here, this is a channel that I'm using as an example, sort of channel that I manage. And we have this ability to use trusted publishers here. And we have currently one trusted publisher enabled, which is the RustForge build YAML file. And I could go and add another one, for example, from my own account. Repository name, let's say foobar. and the workflow is workflow.yaml. And when I click on submit, this trusted publisher is added. And that means that if I had a repository that is called foobar under my own GitHub user account, and the workflow that is called workflow.yaml, like that's actually the file name, then I could just directly publish to the RustForge repository. But I'm going to remove this, and now that ability is gone. But in the RustForge repository itself, that we can also look at, we do use this mechanism now, since this morning actually, to publish the packages. And what this looks like is you need to set this permissions ID token right. And then everything to do the actual publishing is integrated into Rattler build. So Rattler build will actually do the API request to the GitHub API to get that secret token that I was talking about, etc., etc. And so when this is configured correctly, then all you have to do is Rattler build, upload prefix, and then select your channel, and then the file that you want to upload. So that's super convenient. Like no more dealing with API keys, etc., etc. Yeah. So that's the gist of trusted publishing on prefix. Since we don't have many visitors, I assume there's not many questions. But yeah, so far this is only enabled for GitHub. If you're interested in having support for this from other vendors like GitLab or Azure or other places that support essentially this kind of workflow with OpenID Connect, and that is something that, like, on the back end we have all the capabilities for. I know that PyPI supports a few more vendors, so I'm sure they support GitLab and I think Google, and also another one that I just forgot, but a few more. So like we would be ready to add more if there's a need, but right now what we're focusing on, or what we really want, is to have a very smooth integration with GitHub, and be able to create these forges. So that's also something that we haven't really shown a lot in the past. So what you can do with this is, like, you can create your own forge that's completely automated on GitHub and uses the Rattler build recipes. In this case, each of these folders has one recipe for some like Rust tooling. It's just fun stuff that we can package if we want to. And so each of these folders contains a recipe, and then in the GitHub action, we use Rattler build to basically build for all of these different platforms. And if we look at what actually happens, then we go, and Rattler build has this mode where we give it a recipe dir. So the recipe dir is the whole repository essentially. And then Rattler build will go and collect all the recipe YAML files. And another feature is that we have to skip existing equals all. And that means that Rattler build will skip all the packages that have already been built and uploaded to these two channels. And in this case, the channel that we're uploading to is RustForge. And we're also relying on CondaForge for like the base layer of packages like the Rust compiler and things like that. And the skip existing is kind of the key to make this work really nicely, because now when you change, for example, the version of this tooling, which is actually the case in here, so only bottom has changed the version number, and then we skip the builds for everything else. And that's great, because that would just be like unnecessary time that we would spend trying to rebuild the thing that has already been built. But the other sort of key piece is that every build in the Conda universe always has this hash, and this hash is made up from the variant. For Rust recipes, these variants are very simple, because Rust packages usually don't have any dependencies. But if you would have any dependencies, and like they are linking to that, and you want to update the dependency, that means that the variant hash would change, and that would also mean that we would not skip the rebuild anymore. We would actually execute the rebuilds, the rebuild step here. and build and upload the package. So that's kind of like all of this, what I'm just describing, is also more or less what happens in CondaForge, but on a much larger scale, of course. But I'm showing this because I think part of our vision is that we want more people to create Conda packages, and this ability to create your own forges is part of that vision. And trusted publishing is one more piece on the way to get there, alongside with like these abilities to run your own forges, and everything should be very neatly integrated with GitHub. And then the next step that we are envisioning is to integrate with Sigstore for basically artifact signing. And that means that when you publish a package from your GitHub repository to the prefix channel, that you can also upload an attestation. And Sigstore and GitHub already have a tight integration as well there, so that you can sign an arbitrary artifact using Sigstore with your user account essentially on GitHub. And we would then sort of verify that signature on our prefix server and add that attestation to your package, so that you can have a little check mark that says that you have a sort of verified artifact. Yeah, so I think that is basically more or less all I wanted to show on that front. We also did a lot of development in Rattler build in general over the last 2 to 3 weeks. One thing that we're pretty excited about is the new, or like sort of improved, cache implementation. I can also show an example of that. So this is a little bit more. Or Ruben, if you have any questions right now or things that you think I should go into, you can also let me know.
Yeah, no, I think it's great. Please continue.
Okay. Yeah, just want to make sure that I didn't skip over anything. But yeah, one of the things, like I just mentioned, is we are trying to sort of finalize the implementation of the cache. And this is a topic more for like, people that have been dealing with Conda packaging for a while. But in Conda build, you had a top level sort of build and then multiple outputs. And all of that was always super implicit and very hard to understand the logic behind a few of the things that Conda build was doing. And with Rattler build, we're like, one of the big goals has always been to like really, really clean all of that up and make it super user friendly. And what we are trying to finalize now is this cache thing. So what you can have is you can have outputs, and each of the output produces one package or multiple for variants. And the cache runs before any of the outputs. And in the cache step, you can essentially sort of pre-build a lot of the things, and then you can distribute that to the different outputs. Or you can also, and this is the new thing, is you can continue the build inside of the output. And so what we did is basically in the cache, we will already fetch some source code, and that source code will also apply to each of the outputs. And we store the dirty work directory where you are like executing the build and doing things. We store that and we move that to a different place, and then we restore it for each output. So each output, when you have the cache defined, each output will basically start wherever the cache has left off. And also all of the files that you are installing into the prefix at the caching stage, those will also be restored into each of the outputs. And that means each of the outputs can also select from the cache, basically. So one thing that you could, so this is like slightly dirty right now, this example, because I was showing this the other day, and so we edited it a little bit. But this is, so in this example, what we're doing is we have a random like C++ project that's called calculator, and it has Python bindings. And the cache will build the Python bindings first. Just regular CMake, like make your build, cd build, CMake, blah, 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 ninja install. And then it will be split into two packages. So the first one will be the lib calculator, and the second one will be the Python bindings to the calculator. And now the other key thing is, I already talked a little bit about variants. So here we only select Python with no sort of version. But then we inject different Python versions in the variants.yaml file. So what we will end up with, or what we should end up with, is one lib calculator that has just the C++ library, and then two Python binding versions. Let me just remove this testing stuff. And what happens is that we will run CMake again here. But like I said, we can already cd into build without having to make your build, because we are starting from wherever the cache has left off. And then we can run CMake again, but this time we'll pass the build Python bindings equals on. And then we run ninja install. And this one also depends on lib calculator in the host. So we already depend on this package. And what happens when you do that is that any of the files that are already installed by lib calculator, which are all the files that come from the cache, will not be part of the PyCalculator package, only stuff that's added sort of afterwards. And now I can try to run this, and I was actually I'm actually not super well prepared, like I already said. So let me just make sure that I have the right version of RedLab build. So this is going to be in the next release of RedLab build. We already merged it. There are still, and it's also still only available behind the -- experimental flag, because we are not 100% sure that we have all the, like, we want to make sure that this has like some sort of level of stepification. Like we want to write a content enhancement proposal, or we have written a content enhancement proposal that defines all of the, like keys and values and things like that in the cache key. And we want to make sure that this is solid enough before we remove the experimental flag. So now I can use that RedLab build that I just built, and I can say build, and then recipe is recipe. And like I said, I have to pass the experimental flag, otherwise it will complain. Let me make it bigger. And if we look, okay, this is not so great, but up here should be okay. So what happens is we build a lib calculator, like I said, and then PyCalculator Py311 with Python 3.11 in the variant, and PyCalculator Py3.12 with Python 3.12 in the variant. And now the first thing it does, it says it's running the cache build, and it's using a cache key, and that's a hash of like a bunch of things that go into the cache, like the build script, the sources, the requirements, etc. And then each of the outputs basically will refer back to the same cache key, and then restore the cache from that cache key. So yeah, we see that a few times. And well, that's basically it. It like finishes the build and builds all the packages. And we can also inspect that in the output. So we have this lib calculator and PyCalculator, two different packages that should be built against two different versions of Python. And we also have this build cache. And if you want to like inspect that, that's essentially like this is the hash that we saw, and we have the new files from the prefix. So in this case, like as I said, this only goes up to the cache. So this has calculate HPP and lib, blah blah blah, where we have the shared libraries and CMake files. And we also store the work dir, like I mentioned, so that we can sort of restart from where we left off. which has the source code, etc. So that's how the new cache implementation works. If you are interested in this, then please join the discussion in the SEPs. So the SEP is here. Define the cache key for V1 multi-output recipes, and Axel from Counterforge has already helped quite a bit in the design here. You can have the nice rendering. Yeah. Any comments on this SEP, any activity is always super appreciated because we need more people to help design this.
Thanks. That was great. Also learned a lot today. If there's no questions from the team, I will say it's done for today, and hope to see you next time if you're watching later. Thanks for joining in if you did. Bye.